So besides storing current max for each of the DP 0, 1, and 2, and 3, I think we need to introduce one more variable, which is current minimum. We need current minimum because if there are negative numbers, and as we have seen here in this DP of 2, that when we encountered -2, then our number is going very down, -12. But we don't know that whether the following number, the next number, is a negative number or a positive number. Maybe if there's a positive number, like in this case, we have to check if we multiply this number with -4, then the number would be like even more negative. But it would be sorry, if we just have another negative number here and the next one, so it means that if we have got even number of negative numbers, in that case the number will become positive. So that's why we have to just not maintain the current max, but we have to introduce a new variable as current min. So let's see, I mean, how it will impact our solution. I think it will, we have to just maintain the current max and current min for each of the indices in this bottom up approach, and see what would be the current max after using both current min and current max. Here we will solve for a different input with -4 here, so that we have to check whether our current minimum approach will give us the correct solution here. So for DP02, so besides we have already used temp1 for current max into num0, we have to use also num temp of 2, which would be current minimum multiplied by nums of 0. Okay. So this is the formula for temp2, which would be 1 same because this is the very first element, and it would be 2. So we have got both 2 here for current max and current min. And now current max, it should not be just the max of temp1 and temp2, because we have to also introduce temp2 here. So it means that the current max should be max of temp1, temp2, and number itself. Similarly, current min would be minimum of temp1 and temp2 and number itself, because we have to calculate both current max and current min, like we're using these two formulas for as a sliding window. We have to calculate for all of them. So after doing this, the current max here would be, let me remove this. So the current max is maximum of temp1, 2, 2, and 2. So it would be 2. And similarly, current min would be also 2, as we have given here. Now for the result, it with the same formula, we have to only check between result and current max. Suppose if there's a different problem that we have to find minimum product sub-array, we can also use the result as minimum of result and current min. But because using this approach, we can find both maximum and minimum. If the problem is changed here in your in the given problem, if it is asked that for minimum product sub-array, the same formula will work for both the cases. So here let's calculate for max first, because this is our problem right now. Max product sub-array, it would be 4 and 2, so it would be 4. So I'll mark it as 4 here. Now let's go for DP1 for these two elements. Temp1 we already calculated before, so for temp2 it would be current minimum, which is 2, multiplied by the number itself, which is 3. So it would be same as temp1, and the current max would be maximum of temp1, 6, and number itself is 3, so it would be 6. So if I write it down, 6, and 3, so it would be 6. And current minimum would be minimum of 6, and 3, so it would be 3 here, right? And so let's write it down here, 6, and 3. And the result would be the current result is 4, and the current max is 6. So it changes to 6 now. So the DP of 1 is 6. Now let's go here. For temp 1, we have already calculated before, and let's check for temp 2, which is current minimum is 3 multiplied by the number itself, which is -2. So it's -6. Now for the current max formula, again, it would be maximum of -12, -6, and -2, right? So it would be -2. And current min would be minimum of -12, -6, and -2. So it would be -12. Now here we got this -12 here as current minimum, which will affect, I will see in the DP3. If we have got -4 input here, then we'll see that what's the output. Again, let's calculate the result first. Result would be max of result. Result is 6, and current max is -2, so it's still 6. So I put 6 here, current max as -2, and current min as -12. Now for the last, I mean, we are using this this array, right? So you are using -4 here. Okay. So the temp 1 is current max. Current max is -2 multiplied by -4 is 8. Let's check for temp 2, which is current minimum, which is -12 multiplied by -4, and it is 12 for the 48. Got a positive number here. Okay, and then current max here in this case would be maximum of temp 1, temp 2, and num psi. So it would be temp 1 is 8, 48, and -4. And then we got this correct value as 48. And similarly for current min, for the same temp 1, temp 2, and temp 3, the current min would be -4, right? So I put 48 and -4. And if you see the result here, the result is maximum of 6 or current max 48. So it would be 48, which is the correct solution if we have got input like 2, 3, -2, and -4. Right? So here, this is the basic formula that we have derived, that instead of calculate just using the current max, we have to also introduce current minimum, the second variable. And then we have to calculate as a static window approach, that what is the current max by storing into temporary variables, and then calculating the minimum out of it, and maximum out of it. And then finally, we use this result to calculate what is the maximum possible for all the combinations that we have here in various DPs. And we arrived at this result as 48. So this formula would work. So whatever the formula that we have derived here, we will solve the same in Java in the next video. So see you all in the next video.